As per the previous class, it is like a circular orbit, only one single law is just sufficient, that is t square proportional to r cube. And I have given the sufficient information related to that. If it is in a circular orbit, what is the total energy? What is the time period? All that relations I have given in my last class. But practically, if it is a one single planet around one star or one single satellite around a planet, it is mostly circle. But when there are more, there is something called perturbation theory, because of which this explains it is a bound but not circle. So bound and not circle, the other possibility is ellipse. So Kepler is the first person who proposed that the shape of the orbit is ellipse. And already by this time you would have learned something about ellipse in mathematics. Even in 10th class also you have. Please try to understand. Ellipse will have two focus points. You can see that over here. One focus is here, the other focus is here. Frankly speaking, in my childhood, our teachers used to made us to draw ellipse. For this purpose, we used to pin two holes and fix two nails into that, and we used to tie a string whose length is more than the distance between the two poles. And we use it to hold the finger here. Here we use it to fold the finger, and we used to move around these poles. In such a case, the structure will be ellipse. So as per first law, which is called law of orbits, every planet revolves around the sun in an elliptical orbit with sun at one of the focus point. Once you set focus, you need to know some geometry related information about this. What is that? Remember, this distance is called major axis distance, which is called 2a for our general purpose. And this distance is called minor axis, which we will call as 2b. Wherever in world you say general notation, 2a, 2b. A stands for semi-major axis distance. B stands for semi-minor axis distance. Also, this distance is called AE. E is a constant related to that circle, and that is called eccentricity. The term E is called eccentricity. Right. For ellipse, the geometry is, if this is AE, this is A. And this every student need to remember, because geometry is very important. And this but geometry is more than sufficient for me. The first law focuses on law of orbits. Every planet revolves around the sun in an elliptical orbit with sun at one of the focus point. Whereas the second law deals with, so indirectly, it is from law of conservation of angular momentum. Remember, if sun is taken as the focus, with respect to sun, the only force is gravitational force, and which is always directed towards the center. So such a force cannot contribute a torque. Therefore, the angular momentum of the planet is always conserved if the only force experienced by the planet is the gravitational pull of the sun. Now, for example, you take a general case where initially it is at position r bar, now it is at position r bar plus dr bar in a very small interval of time. We will say that this is the area swept by the radius vector. That is called area swept by the radius vector. What second law states is, according to Kepler, every planet cover equal areas in equal intervals of time, or the aerial velocity of a planet is a constant. Area covered dA by dt is a constant. Aerial velocity is a constant, means it covers equal areas in equal intervals of time. In fact, this is drawn from law of conservation of angular momentum, and believe me, I'll explain how it is. Now, for example, you take area. You know already in vectors how to determine the area of this triangle. It is a half into r bar cross dr bar. You know this already. So therefore, dA by dt is nothing but half r bar cross dr bar by dt. Dr bar by dt is nothing but v bar. Now, this can further be written as r bar cross mv bar by 2m. Agreed? But what is r bar cross mv bar? Vectors, angular momentum. And you know there is no torque in this case, because the only force cannot contribute torque because it is a central force. So therefore, torque is zero, so angular momentum is a constant. So aerial velocity is a constant. Actually, what is the law? Aerial velocity is a constant. Why it is a constant? Because angular momentum is a constant. So therefore, because angular momentum is conserved, aerial vector is constant. That is about second law of Kepler. Kepler's second law. And this law is also called as law of areas. And the last but not the least, third law. What is the third law? Law of time period. According to him, the square of time period of revolution means from here back to that point is one revolution. It takes, say, for example, capital T time. Then, for such a ellipse, T square is proportional to A cube. T square is proportional to A cube, and T is nothing but 2 pi root A cube by G capital M. This is Kepler's third law. Square of time period of revolution is proportional to cube of semi-major axis distance. And not only that, the total energy of an object in an elliptical orbit is always minus g capital M small m by 2a as per Kepler. This is Kepler's third. Remember, as long as you are dealing with the elliptical orbits, the fundamental rules in solving any question is apply law of conservation of angular momentum, but it should be applied strictly about law of conservation of angular momentum about sun. Similarly, you can apply law of conservation of energy. Only these two steps are there to solve any problem. Now, for example, you see here in this ellipse, you notice 2 points. This is the nearest point. This is the farthest point. For angular momentum to be conserved, this is a less distance. This is more distance. So here maximum velocity, here minimum velocity. Because the farthest point, so therefore least velocity. So therefore this point is called, this particular point is called perihelion. And this particular point is called ephelion. Sometimes they are also called as perigee and apogee, both. That language is also there. Perigee, apogee. This is perigee and this is apogee. Away, ephelion, apogee. Okay, that is how you need to remember. And not only that, now you know for ellipse, as mentioned, this distance is AE. If this distance is R1 and this distance is R2, then clearly R1 is nothing but A into 1 minus E. And R2 is nothing but A into 1 plus E. From this, you can get this expression. For example, at this point versus at this point, angular momentum is conserved. V max into A into 1 minus E is V minimum into A into 1 plus E is V. At this point, velocity is V. Okay. So, but angular momentum purpose ke liye, this angle is 5. Right? This angle is 5. So R bar cross MV bar gada. So you will get that part as, you got a point? So at this point, if this makes an angle 5, R bar cross MV bar becomes RV sin 5. M cancel చేస్తాను M. Cancelled M everywhere. So, if this you know, you can do maximum problems. Please try to understand till this point of time, till yesterday's class, no difference between electrostatic models and gravitation based models. There, whatever the formulas that you are using, same formulas you can modify and you can apply here. Cavity problems there versus cavity problems here, more or less the same. But ellipse-based problems, whatever I am going to discuss now, is totally different from the knowledge what you have acquired in electrostatics. So that is how this class is different. Whatever I thought till this point, only on this I will do maximum problems. See. Right. Now you go with the first question. It's a very simple question. Can go with first question, which is a very simple question. A planet going around a star in an elliptical orbit has a semi-major axis equal to A and eccentricity equal to 1 by 2. Speed of the planet when it is nearest to the star is V1. Find the speed when it is at the farthest from the star. Hold on. Remember, this is the ellipse. Right. Now, this is the semi-major axis. And this is the semi-minor axis. And that is the focus point. That is the focus point. Let this be R1. Let this be R2. And this is the V nearest point means V1. This is V2. But we have relations right now. What is that? V1 is G capital M by A times 1 minus E by 1 plus E. Sir, where do you got these relations? I told you very clearly from applying law of conservation of angular momentum plus law of conservation of energy, we got this relation. Now V2 is equal to Gm by A into 1 plus E by 1 minus E. They have given V1, they are expecting us to find V2, right? V2 by V1 is given as V2 by V1 is given as 1 plus E by 1 minus E whole square. Right or not? Just substitute the value. You have E is equal to 1 by 2. Just substitute the value. So when you substitute the value, you will have 1 plus 1 by 2 by 1 minus 1 by 2 whole square. 3 is to 1. Done. Simple question. A very simple question. Do you have any doubt on this? Pakka? Right. Now read this question. Don't worry, I'm posting the notes. I hope everyone have gone through the notes yesterday. And I have posted that YouTube link also. Right. Not for you, actually. Actually, it is not for you. But in case in future, if you want to refresh one more time. Right. Since its predicted return in 1759, Halley, name of the scientist who discovered that planet. 1759, Halley's comet has come back to us 3 times. Once in 1835, the other in 1910, and most recently in 1986. I still know, first time I have observed in TV that time, the tail, the remnants of Halley's comet strike in Jupiter. Some of the remnants of that Halley shoemaker. So that is the first time where some celestial event was recorded and broadcasted. Right. It is orbiting around the sun with a time period of 76 years. In 1986, it was nearest to the sun at its perihelion at a distance of, as 1986 after some time, around 90s, 1994, 1990, up that period. Right. Mass of the sun given, radius of it is a perihelion at a distance of r1. Okay, basically it is a moving, means it is an elliptical orbit. Very clear. Now, can you please help me in rewriting the data properly? What is R1 according to him? R1 is A into, this is 8.9 into 10 to the power of 10 meters. Agreed? Yes. And they have given time period, don't forget. But we know what is time period. T square is equal to 4 pi square A cube by G capital M. T square proportional to A cube. We know this relation. Right. Now tell me what data I have. I have time period data given a mass of the sun given G, I know. With this I can get A. So A is G capital M T square by 4 pi square whole to the power of 1 by 3. ఇప్పుడు సబ్స్టిట్యూట్ చేసి క్యాలిక్యులేషన్ చేస్తే అవ్వదు మనకి టైం. సో నేను చేశాను ఆల్రెడీ అది. So therefore, after proper substitution of the given data, G we know, capital M they have given, T they have given. Substituting properly A nearly in calculator, you will get it as nearly 10 to the power of 12 meter. Now you got A. I can find E now. How? A into 1 minus E is 8.9 into 10 to the power of 10 meter. So with this, I can say 1 minus E is 8.9 into 10 to the power of 10 by A, 2.7 into 10 to the power of 12, which implies E is nearly 0.97. Don't worry, trust me, I have done this question. Why? Because calculation is a criteria. Even tomorrow in VAT exam or all, you'll face the same problem. This question is arrived. You're out. Don't say I'll remember 0.97. What if they change the numbers and all that? No, I am just giving you basic models right now. Now you got E. You got E, you know A, you can find whatever you want. What do you want finally? Calmest farthest distance. R2 is A into 1 plus E. You substitute, you'll get the answer as 5.3 into 10 to the power of 12 meter. Clear? Right. So any doubts in this question? And he is very great. He has given some values, 19.4 whole power 1 by 3. All that stuff he has given. Okay? Right. Next question. Don't worry, I'll post you this. Next question is example 28. It's a very simple question. Right. Any doubts in this question? From a circular orbit to elliptical orbit. Change. See, a satellite of mass m is going around Earth in a circular orbit of radius r. It has time period t1. T1 is a time period in circular orbit. Right. A small rocket is fired from the satellite, which decreases its speed by 4%. And a V0 speed ఉండేది 0.96 V0 అవుతుంది. Right. Almost instantaneously. So there is no time lag. Direction of motion remains unchanged. Now the satellite moves in an elliptical orbit because that you have fired. Find the semi-major axis in terms of R. Find the time period in terms of T1. No issues. Now this is the planet. Right. Actually, this is the circular orbit as of now. Right. That is the circular orbit. Good. Now, since we don't have any work, we have fired bullet. So what is happening is it will reduce the speed actually. Remember, initially, it is in a circular orbit of radius r. So what is going to be the orbital velocity? Root g capital M by r. Right. Now see, just after firing the rocket, speed becomes 4% less, means 0.96 V0. During this period, don't conserve energy. Once this is done, you can conserve energy. Why? The only force is gravitational force, and that is conservative. Now the issue is, what is the kinetic energy right now? Exactly what is the kinetic energy right now? So I am taking all the content just after firing. Kinetic energy right now is half mv square. 0.96 square will be 0.92 into half into m into v square, v naught square now, means g capital M by r. That is the kinetic energy. Can I apply kinetic energies to potential energy, total energy relation here? Wrong. That is applicable only for circular orbits. This is no longer circular orbit. It is an elliptical orbit. Right. Which means, and that too, this is slow. Hello. This is a lesser velocity. So actually, it might go in a path like this after that. So I am assuming. Now that is the kinetic energy. The potential energy is the same as old minus G capital M small m by R. So what is the total energy? Kinetic energy plus potential energy. So by doing this, what I am getting is area 92 means 0.56. 0.56 minus 1 G capital M small m by R. Don't worry, negative వస్తుంది bound. 1 minus 0.6 అంటే minus 0.44 అంతేగా nearly. G capital M small m by R. Don't forget, this is a elliptical orbit. For an elliptical orbit, equation 1. For an elliptical orbit, This should be small m, capital M by 2a. 2. For an elliptical orbit, that is the condition. Ellipse. So I will equate RHS of equation 1 and equation 2. So what I am going to get is A from this. So A nearly, how much I will get? Nearly, how much I will get? Just please help me, my steps. 0.56, 0.46. And this will become 0.54, 0.54, 0.54. Okay, right. Now you equate, you will get the value of 0.54, correct? Na? Sure. Minus G capital M small m by R, right. The total energy is nearly 0.54 G capital M small m by R. So therefore, you will get A nearly as here, what you do is 2A is equal to R by 0.54. So A will be 100 by 108 times R. That works nearly 0.93 R. So first part of the question I have done. Any doubts, boys and girls? Next. Now tell me how to compare time periods. Straight formula. How to compare time periods? T square proportional to R cube. So therefore, T2 square by T1 square is A cube by R cube. Literally, this is 0.93 cube. 0.93 cube. So you express it in terms of T1 is what they said. So that I will write as 0.93 times 3 by 2 times T1. So in calculator, I got this as 0.89 T1. You may ask me why you have done earlier, because I know time is criteria for me today. If I start doing, what is important in this? The concept is important. Who cares for the calculation part? You should care for the calculation part while doing this in exam. Any doubts, boys and girls? So I am dealing at a fundamental level. So till this point, I've used the same equation. Right. Next. Are we clear related to this question? So I'm proceeding further. Excellent question again. It's a very question. Everyone go through the question carefully. You better, you should hesitate now. I am using the same concepts again and again for the next 4 or 6 questions. An asteroid of mass M is approaching a planet of mass capital M. Asteroid mass is negligible. My point is, planet won't move towards the asteroid. That's point. Right. The speed of the asteroid is u at the impact parameter. Impact parameter is farthest distance, perpendicular distance. The asteroid just missed the planet. Just missed the planet means this is your planet. And this is the asteroid. And it follows a path like this. Just miss kana. That's just miss. Any doubts till this point? You are having velocity u over here, and you are having a velocity v over here. Remember, just miss means it should be tangential. And angular momentum, law of conservation of angular momentum states that MUT is the initial angular momentum. Any confusion in that? ఒరే ఇప్పుడు ఇక్కడ మాట్లాడరు, ఆ తర్వాత ఎప్పుడో ఆ ఎంయూడి ఎక్కడి నుంచి వచ్చిందని ఆలోచిస్తారు, అయిపోయింది క్వశ్చన్ మొత్తం. మీరు స్టెప్ వేసేటప్పుడే అడగాలి, వేర్ డు యూ గాట్ ఎంయూడి టర్మ్? You know, angular momentum, this is the perpendicular distance. This is the direction. This is the direction. And this is the perpendicular distance. Momentum into perpendicular distance is angular momentum. Right. Next. Fine. What is happening thereafter? Is equal to mvr, equation 1. Why again d? mvr. That is the first part. So therefore, wherever I have v, I can use, and one more, d given as a 2r. Wherever I have v, I can use it as 2u. Right, done. Now, law of conservation of energy. What do law of conservation of energy states here? We are infinitely far from the planet. Initially, what is the form of energy? Only kinetic energy. Half m u square. When it is just grazing, right, it is minus g capital M small m by capital R plus half m v square yu square. At that point, velocity is v. So by solving which, you just solve these two equations. Okay, in this case, half m u square is minus g capital M small m by R plus half m v square can be written as 4u square. So by proper adjustment, you will get that relation as u is equal to, you will get u straight away from this. Ante kada? You will get u straight away from us. 3u square is equal to 2g capital M by R. Agreed? And this is nothing but wherever you have this, I said you write like this, 2r. So therefore, u is under root 2rg by 3. Any doubts? That's it. I have applied only two equations. One is law of conservation of angular momentum. The other is law of conservation of energy. Any doubts? Are we clear? So I have solving these problems by using fundamentals. Right. Very simple question. You know how to do this because I have already delivered necessary content by this time. Read the question carefully. Satellite is suddenly stopped in its circular orbit and released. Show that the time in which it will fall on the planet is 1 by 4 root 2 times original time period of revolution. Assume that the original radius of circular path of the satellite is large compared to the radius of the planet. In this case, you should imagine that the planet is of the size of a point mass. And the actual circular orbit is like this. Right. Now what happened? And you just dropped. Are almost Aswatthama type. Almost. Behaves close to a very small ellipse. Small bole to, so very small minor axis. Sir, why you are doing all these things? I have a reason. Now, here R1 is a capital R. R2 is ellipse, semi-major axis. R by 2. Then, if in this time period is a T1, in this time period is T2. So T1 square by T2 square is R square by R square. अरे यार R square कैसा है? R cube by R cube by 8. So therefore T2 is T1 by 2 root 2. But that is not your answer. Why? अरे भैया पूरा घुमाने के लिए T2. But you are striking straight away to earth, no? There is no return path. It is a one-way path. So therefore, the time required for you is T2 by 2. And this will become T1 by 4 root 2. That's your answer. It's a standard question. Any doubts? Pakka? Now, please try to understand if you are doing action as if that you are following, you are cheating your own. Remember, the moment when I take the charge, I will stress on marks. Be careful. Be careful. So therefore, if you say, I don't remember, I forgot, I did not understood it properly, I won't spare. And all this class is a recording proof. If I write it, you may say after the class you would have written that there is no proof that you have done that in the class. So this is recording. There is no compromise. So pay full attention. Any doubt till this point? I'm asking for the last time related to this question. Next, good question. Array, don't mind, I am discussing the same questions again and again and again and again and again. In spite, you might spoil this in the next Sunday exam. So carefully you should do the question. Now take this. Please go through this question. A planet is going around the sun. You can see sun is a focus point. At a certain instant, distance of the planet from the sun is R0. And its speed is also given. Okay, V0. And angle is also given, fortunately. Calculate the maximum and minimum distance of the planet from the sun. See, you tell whatever the reason, I have the only observation like this. This is V0 sine theta. And we will call this point as B. V. And this is R. Okay? Which means apply law of conservation of angular momentum at A and B. If I do so, what I will get? V0 sine theta times R0 is V into R. Equation 1. What are unknowns here? They have given V0 and R0 terms actually. So V and R are unknowns. We require one more equation. What is that equation? Law of conservation of energy. So applying law of conservation of energy at the same 2 points. So what we will have is half m v square minus g capital M small m by r. This is at A. At B, sorry. At B. At A, what is going to happen? Half m v naught square minus g capital M small m by r naught. Any confusion? V naught sin theta radha anukunara? No, you should not write. That's it. This is at A. Right. Equation 2. Now from these two equations, you will get an expression for R, small r in terms of R naught. You will eliminate everything. Fortunately, they have given V naught for you. By from 1 and 2, from equation 1 and 2, After working 1 and 2, you will get an expression in terms of R and R naught. Right. So that is going to be 12R square minus 16R R naught plus R naught square is equal to 0. You will get a quadratic equation like this. Energy. What is the speed at A? Tell me. V naught. So what is the kinetic energy at A? Right? I know that is the reason why uttered intentionally. Such a mistake you will do. That is a wrong concept, not silly mistake. It won't be graded as silly mistake. It's a wrong concept altogether. Now, this quadratic equation gives you two results. One, R is equal to 16 R naught plus or minus root of B square. 16 square R naught square minus 4 AC. 48 minus 48 R naught square, right? But how is this possible? 1 minute. Let me just see. 16 square minus 48 R naught square root on right divided by 24. So you will get this as 4 plus or minus 13 divided by 6 R naught. So why I got 2? I'll explain. If it is 4 minus 13 by 6 times R naught, this is the minimum distance. If you got 4 plus root 13 by 6 R naught, this is the maximum distance. Calculate maximum and minimum distance is the question. So I have done both. But remember, the moment whenever you see such a question, what should strike in the mind? Apply law of conservation of angular momentum, a law of conservation of energy properly. Till this point, any doubt? Clear? Now, I don't want to spend much of time. Please try to understand why I am doing this. I don't want to spend much of time in drawing from year to year because I can do more number of problems in that time. Right. Next, a satellite of Earth is revolving in a circular orbit. In a circular orbit of radius r. Fine. A gun in the satellite is aimed directly towards the Earth. Okay, right. Evadukunda sadatho adukudi enduke why anta veduku, that is the question given. Next, it fires a bullet with a velocity equal to half the orbit speed of the satellite relative to the satellite. The satellite is massive and its recoil can be neglected. Find the maximum and minimum distance of the bullet from the center of the Earth during its subsequent motion. I require some geometry for this purpose. I require some geometry. This is Earth. Fine. This is the expected circular path. Fine. And this is the expected circular path. Fine. Now, at this stage, what is happening is that the satellite is moving with orbital velocity V0. And remember, the radius is x. Right. Now you are projected with V0 and speed V0 by 2 towards Earth. So the resultant velocity is in this direction. So the resultant velocity is V0 square plus V0 square by 4, which is root 5 by 2 V naught. And don't forget, V naught is nothing but root G capital M by X. Don't forget that. Doubt on that. You know why you will do a mistake? I'll explain. You will compromise it. At the end of the day, sir, I didn't follow that problem. You will express. You know why? The very first step is the problem for you. Why you should compromise? Better you question me how that step arrived. Only then you will get a topic full clarity. Right. Now, as a result, what will happen? As a result, what will happen is that the orbit will be corrected and it will follow an orbit like this. It may follow an orbit like this. Till this point, any doubt? Right. Now, don't forget this line passed through the center of the Earth. Now, we will call this point as A. The point is A. And the farthest point, as of now, I am assuming B, which will be R. Array. Do you find any difference between this question and the previous question which I have done? No. Now then what is that my step is going to be? Apply law of conservation of angular momentum between A and B. Fortunately, since this passes through origin, mv naught x is the angular momentum at A. Whereas at B, I have no idea, let the velocity be. And let the distance be r. mvr, equation 1. Right. Now I have one point and I have understood two variables are there, v and r. I require one more equation. Apply law of conservation of energy between A and B. See, remember, lot of people will have a confusion. Don't apply law of conservation before firing, not during firing. You can apply law of conservation of energy only after firing. Right. So after firing, after firing, half m their velocity is 5/4 v naught square minus g capital M small m by x is equal to half mv square minus g capital M small m by r. So the entire thing is equation 2. Again, from equation 1 and equation 2, you will get a quadratic equation. And that equation will be of this form. 3r square minus 8rx plus 4x square. Tell me, do you find any difference between the previous question and this? So you will get a quadratic equation, and for this, there are two roots. R can be 2x or R can be 2x by 3. What is 2x by 3? What is the meaning of 2x by 3? Almost it will intercept Earth. It will intercept the Earth. It will intercept the Earth at some point. Get the point? So that's the deal. Right. Any doubt in this question? So till this point of time, whatever the questions that I have done, majorly what concepts I have applied? Law of conservation of angular momentum and law of conservation of energy. Right. Go ahead. Now this is the next question. Fast. Read the question carefully. A satellite of mass m is going around the Earth in a circular orbit at a height r/2 from the surface of the Earth. The satellite has lived its life and a rocket on board is fired to make it leave the gravity of the earth. Because I don't want to use that space. Right. It should escape otherwise. The rocket remains active for a very small interval of time and imparts an impulse in the direction of motion of the satellite. Neglect any change in the mass due to firing of the rocket. Find the minimum impulse imparted by the rocket to the satellite. Find the minimum work done by the rocket engine. Mass of the earth given, radius of the earth given. And you are at a height r by 2, which means the radius of the orbit is r plus r by 2. So at that point, the orbital velocity required is g capital M by r. This is going to be 2 times z capital M by 3r. Any doubt? With this velocity, what happens? It revolves in a circular orbit. Actually, it revolves in a circular orbit. Right. Now you want to escape. So all of a sudden, how much velocity is required? Yesterday I have given that. Root 2 times the orbital velocity. If V becomes root 2 times V naught, it will escape. Very simple. So for the satellite, you are giving an impulse such that initially the velocity is V naught. Finally, the velocity is root 2 V naught in the same direction. Initial, final. So therefore, J is equal to M times root 2 V naught minus M into V naught. Root 2 minus 1 M V naught. Right. So you know impulse. That's all. That's the first question. Which means root 2 minus 1 M times 2G capital M by 3R. Whatever the data you have provided, in that terminology only I have expressed the answer. Right. Minimum work. No change in potential energy. Before impulse, after impulse, same distance. So no change in potential energy. What we will notice is change in kinetic energy. So whatever the work that is done, that is equal to change in kinetic energy. Final is half m root 2 v naught square. Initial is half m v naught square. So what is going to be the factor? It is simply half m v naught square. Here half m v naught square is nothing but g capital M 2g capital M small m by 2 times 3 capital R. So therefore the answer is G capital M small m by 3 capital R. That is the work pattern. Do you have any doubt in this point? Are we clear? Pakka? Any doubts? We are doing problems strictly on very fundamentals. Any doubt? Right. We'll move on to the next question. Next question. Right, go ahead. Assume that there is a tunnel in the shape of a circular arc of through the earth. Wall of the tunnel is smooth by God's grace. లేకపోతే మళ్ళీ అన్నెసెసరీలీ బాల్ ఆఫ్ మాస్ అయితే నేను చెయ్యను రా అప్పుడు క్వశ్చన్ నేను చెప్పరు కూడా. A ball of mass m is projected into the tunnel at A with speed v. The ball come out of the tunnel at B and escapes out of the gravity of the earth. ఆగండి ఏం పర్లా, stay there. Mass and radius of the earth, data. Minimum possible area. You do whatever it means. You are projecting it. V is nothing but escape velocity. And this is nothing but root 2 G capital M by R. Done. First part of the question is done. Now, if the ball is projected into the tunnel with speed V0, calculate the normal force applied by the tunnel ball on the ball when it is closest to the center of the earth. It is given that the closest distance between the ball and the center of the earth is r by 2. ఇక్కడ ఇంకో పాయింట్ కూడా ఉంది. You should care that. And the radius of the is also r. Right. Hold on. First point is, just because you have thrown, the entire planet won't shake. It is as it is. So it is at rest. Now, the moment when it reaches this point, let the velocity be u. Let the velocity be u. Now, you know total energy at A is 0. So total energy at this point must also be 0 because law of conservation of energy. Yet A total energy is 0. How do you know? You said it should escape. So let this be point C. Yet C also total energy is 0. For this purpose, you need to know this formula. Potential at a point which is at a distance r from the center of the solid sphere is minus G capital M by 2r cube times 3 capital R square minus small r square. Just please confirm whether you know this or not. Right or not? In electrostatics, you have learned. Actually, there you would have learned it as a k cube by 2r cube times 3 capital R square minus small r square. You need to know this. So therefore, potential energy plus kinetic energy is 0. So what is going to be the potential energy at this point? Minus G capital M small m by 2r cube times 3 capital R square minus R square by 4 plus half M U square is equal to 0. Any doubt? Boys and girls. So finally, you can write this as U square is G capital M by R cube times 11 by 4 times R square. So therefore, U is nothing but 11 G capital M by 4 capital R. That is not your question. They want normal reaction. By the way, don't forget this is also a circle. At this point, you have a velocity u. Okay, right. And this object is experiencing gravitational force. And by the way, this is inside some tunnel type light. So this will experience a normal reaction. So now something should contribute centripetal acceleration towards the center to overcome this circle. So therefore, n minus fg is equal to m u square by r by 2. Yes or no? Wrong, because you said the circle is also of radius r. So therefore, r by 2 is not correct. It should be r. By the way, even normal reaction, I think the question is force exerted, normal reaction. By the way, what is G? Gravitational force. Gravitational force, inside it is G capital M by R cube times small r. Do you know this? Intensity of gravitational field. Yes. Right. Inside at this point, from the center of the earth, you are at a distance r. Gm by r cube times small r. That is the relation. Do you remember this? Intensity of gravitational field into mass. Now you substitute. So what you will get is n is equal to G capital M small m by r cube times r by 2 plus m by r times u square 11 z capital M by 4r. So by solving which you will get normal reaction as 27 by 4 G capital M small m by r square. Right. Okay. Right. Any doubt? Paka? Next question. Before you go for this question, better you go for this one. Easy question. 59. Geostationary satellite is nearly at a height of 6r from the surface of the earth. Where r is the radius of the earth. Calculate the area on the surface of the earth in which the communication can be made using this satellite. Right. Try to understand what is happening over here. This is earth. And this is the satellite. Now, please try to understand. That is the line of sight. This is the line of sight. Now, please try to understand. It is in a two-dimensional plane. In a three-dimension, actually, this is a cone. So, which means people in this part of the world you can see, you can imagine a cone. Means which this part, this ice cream cup, this part, this part, this part is only affected with the communication of the satellite. Rest, no one have an idea that such a satellite exists. Now, very clear, geometry is important here. Geometry is important here. Now see, this is 90 degrees. Now this is r distance. And this is 7r distance. And this angle is theta. So from this I can say cos theta is r by 7r 1 by 7. Sir, why you require cos theta? Very simple. For the entire portion which I have shown here, this area part will subscribe a solid angle at this point O. So we know already in electrostatics we have expressions for solid angles. 2 pi times 1 minus cos theta. And this will become how much? 12 pi by 7. Right. Right. अरे यार अगर 4 pi solid angle है तो area covered is 4 pi r square. Full sphere. For 12 pi by 7 solid angle, how much area is covered? अरे यार don't get compromised. Are you clear? For a full closed object, it is 4 pi, you know already. 4 pi r square in that case. But the solid angle which you are covering is only 12 pi by 7. Suppose you place that satellite at the center of the earth, every surface point is covered. So 12 pi by 7. How much is that covered? Which means 12 pi by 7 times 4 pi r square by 4 pi. So which is nothing but 12 pi r square by 7. This much area is covered. Any doubts? Store? Right. Next question. 61. 61. Carefully go through these questions. 61. Yes? Increase. Go through the question carefully. A spaceship is orbiting the Earth in a circular orbit at a height equal to the radius. So and so 6,400 kilometers from the surface of the Earth, almost the radius of the Earth. Which means the height is same as the radius. An astronaut is on a spacewalk outside the space station. He is at a distance 200 meter when compared to 6,400. Almost negligible. Okay, fine, no issues. From the ship and is connected to it with a simple cable which can sustain a maximum tension of 10 Newton. Assume the center of the Earth, the spaceship, and the astronaut are in a line. Gravity cinema mass of astronaut along with all his accessories is 1000 kg. 100 kg. 100 kg is a very small actually. He'll carry even more than that actually. Do you think that a weak cable that can only be a load of 10 newtons can prevent him from drifting in space? Make a guess. Hold on. With that numbers, I cannot do any guess. With that number, I cannot do any guess, and we should do the problem very sensibly, carefully. Now, follow my steps. You see, you have Earth here. Please follow carefully. No issues, out of focus. We are not worried about what is happening to the left side. Now, here is your spaceship, and here is your astronaut. Do you believe that they are in a straight line or not? Right. Now, what are the different forces? No, you study situation differently. And remember, the angular velocity is omega here. And by the way, any geostationary something like mentioned? No, because at that height it can't be geostationary. Rather, it is close to Earth satellite. You can take not exactly close to, almost like that, because the height of that is 36,400 kilometers. Now here what is happening is, now you take the free body diagram of the spaceship. This will experience gravitational force G capital M naught by R square. and this will experience a tension force. But still it is experiencing a centripetal acceleration AC. So therefore, G capital M naught by R square minus T is M naught R omega square. Equation 1. Any doubt till this point? Right. Now you take the free body diagram of the man. The free body diagram of the man is like this. T and gravitational force G capital M small m by R1 square. R1 is nothing but R plus L. R plus L. Right. And that supplies AC dash. So therefore, this can be written as R1 square plus T is MR1 omega square. Let this be equation 2. See, from these two equations, omega square term is common, actually. So you can express tension properly like this. From equation 1 and equation 2, you can write it as G capital M by R cube minus T by M naught R is equal to G capital M by R1 cube plus T by MR1. Okay, till this point I did not cheated you anywhere. Now I will start cheating you, because when I take R1 square, it's almost the same as R square. Why? You should play. At the beginning only, I introduced that doubt in your mind. Similarly, when compared to the mass of a lorry, a person mass is almost negligible. So whenever it is possible, M naught plus M, I will almost consider as M naught. Till this point, I did not cheat it. So now cheating starts. So with this equation, I can write tension term as Gm by R cube minus Gm by R1 cube divided by 1 by M naught R plus 1 by MR1. So by proper substitutions, you will get T nearly equal to nearly that. Gm by R cube times 3m M naught L by M naught plus M. Remember, R is nothing but 2 times the radius of the Earth. I told you very clearly. R is not the radius of the Earth. It is the radius of the orbit, which is 2 times radius of the Earth. Now, by proper substitution, tension is nearly Gm by 8RE cubed. ఇంకా అవతల ఏం మిగులుతుంది? Almost you will neglect 3 ml. That's it. And after proper substitutions of all these values, you will get 0.01 Newton. Your string has a tension of the order of 10 newtons, and the maximum possible tension in this case is 0.01. 1 by 10,000 part of 1 by 100th part, I think not 1 by 100 part, 1,000th part of your maximum tension. Now tell me any doubt in this. Are we clear? Sure. Everyone in this class? Right. Do you think that a weak cable that can only take a load of comfortably, it prevents him from, it will avoid disconnecting, right? Next question, 62. Make it fast, boys. Read the question. Earth is rotating about its axis with angular speed omega naught, average density rho. It is proposed to make a space elevator. Actually, China is planning now. Space elevator by placing a long rod, here for assumption here, with uniform mass density extending from just above the surface for the earth, of the earth actually, out to a radius of nr, where r is the radius of the earth. Right, hold on. Prove that the rod can remain in above the same point on the equator at all the points. That point is a hint for my question. That point is a hint for my question. All time means it should behave like a all time geostationary satellite. That is a hint for my question. Right, hold on. Don't comment anything right now. Right. Okay, what is that you are saying is that, right, okay, fine. Let me draw the diagram properly. Let me draw the diagram properly. This is the rod, actually. In fact, this is at a distance of nr from the center. Actual length of the rod is n minus 1r. So the center of the rod is somewhere here, and from the center it is at a distance of r plus n minus 1 by 2 times r, and that will become n plus 1 by 2 r. Right, hold on. So I have identified the center. Right. I am introducing a term called lambda, mass per unit length of the rod. Next, don't get confused between the quantities, the center of gravity and center of mass. It is a uniform rod. Center of mass undoubtedly lies at the center, but center of gravity will not lie at the center, and I don't require anything related to center of gravity right now. I just by introducing a new term, I don't want to disturb you, but long time running after this point, you may get a doubt. So your future doubt, I am clarifying now. So don't get confused. It is a uniform rod. Center of mass lies exactly at the geometric center. Right. Now the question is, now you take an element here, a small element here, dx, which is at a distance x. This element will experience a force G capital M lambda dx by x square. It is x from the center. A small element due to the gravitational pull experience this much force. The total force experienced is x is equal to r to nr df. So you will get this value as Gm lambda by r n minus 1 by n. Any doubt? Because we will substitute that. Right. So this is the core point. And this acts inwards. This acts inwards. And this is the cause of center, right. The center of mass is at a distance. Let this be RCM. So therefore, Gm lambda by r n minus 1 by n is m RCM omega square. And remember, this is omega naught is nothing but angular velocity of rotation of the earth. By the way, what is m? Okay, how you will get mass of the rod? N minus 1 L. Therefore, G M lambda by R N minus 1 by N is lambda N minus 1 L, right? Here, length of the rod is nothing but, why should I write this again? N minus 1 into N minus 1 R. Yes or no? Therefore, why should I write again L term? Tell me. Whether I will write it as mass of the rod as 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. Don't get confused. Lambda N minus 1 R. N minus 1 R. RCM. RCM is N plus 1 by 2 R omega naught square. Yeah. Now you tell me, do you have any doubt? Lambda N minus 1. Lambda N minus 1 out. Now what is that you are getting here? R, R, 8 minute. This is R. Don't cancel this. R. Mass. What about the mass of the planet? This can be given as 4 by 3 pi r cube rho. Right? So therefore, you can write this as G times 4 by 3 pi r square by N is equal to N plus 1 by 2 times R square omega naught square. R square cancel. So you want the condition you want is N square plus N is 8G pi rho by 3 times omega naught square. Let me see whether I have proved it or not. This is what I got. Thank God. Any doubt? Clear? What is the concept? Equating forces and linking that to satellite. 3 concepts. Next, 63. A body is projected up from the surface of the earth with a velocity half the escape velocity at an angle of 30 degrees with the horizontal, neglecting air resistance and earth's rotation. Find the maximum height above the earth's surface to which the body will rise. Right. Let me understand the question first of all. Yes, this is the earth. And at this point, taking as a reference, so you have projected it with an angle 30 degrees. So frankly speaking, it will follow some path like this. Well, okay. Right. I have done that. Dotted line represent assumed path for ellipse. I see, my intention is very clear here. I want to give you the feel of ellipse. And this is the ellipse major axis. And that is the maximum distance. Okay, now tell me any doubt till this point. Clear? Now, I think you got the point. This is point A and this is point B. You conserve angular momentum, law of conservation of angular momentum across these 2 points. So at A, what is going to happen? Here you projected with what velocity? Half the escape velocity. V naught is a half of escape velocity. 2g capital M by R. This is nothing but G capital M by 2R. So therefore, V naught again, it is a sin 30. I don't know. What is this? Cos 30 into R is MVR. Yes or no? So therefore, from this V naught root 3 GM by 8R times R is equal to VR. Let this be equation 1. That is the equation 1. Energy conservation. And don't take components again. So therefore, law of conservation of energy step. What is going to be the law of conservation of energy step? Half m v naught square minus g capital M small m by R. Hold on. Is equal to half m v square minus g capital M small m by R. So from this, it is very clear. You will again get a quadratic equation. From the quadratic equation, you can conclude, yes, correct. You can conclude, you will get 2 terms. Actually, you won't take 1 term in that. The quadratic equation from 1 and 2, you will get it as 12R square minus 16 capital R small r plus 3R square is equal to 0. So when you do, you will get 2 terms in this. One is 4 plus root 17 by 6R. The other is 4 minus root 17, root 7. 4 minus root 7 by 6R. So you won't take this. You will only take this one. But remember, that is radius. That's not the answer. That's a radius. So therefore, R is capital R plus H. So H is R max. H is 4 plus root 7 by 6R minus R. So therefore, you will get this one as root 7R minus 2R by 6. That is the maximum height. Any doubt in this? Right. One more and a last problem. Any doubt in this? Last problem. This is the last problem which we are going to do. Read the question carefully and try to solve. With this, I will close the teaching part. The simple question, not a difficult question at all. Only thing that you must have an idea is close to Earth orbit will have nearly some 8 kilometer per hour. The data you must take. So while cutting, I missed it. A near surface Earth satellite has a cylindrical shape with cross-sectional area of S, mass capital M. Here, capital M is the mass of the satellite. It encounters dust. Dust density is also given. Dust particles strike and comes to rest. So the take mean density of the Earth also given. First, what is the drag force experience? Remember, see, please try to understand. Equation of continuity, you have some idea. Velocity into S, volume per second, into density. So mass striking the satellite per second is nothing but S V. V is the orbital velocity at that instant into T. And from system of variable mass, you know the thrust force is minus dm by dt u relative. It is nothing but V only. So therefore, this is going to be minus S V square T. That is the thrust force. In fact, it is a drag force here, which means for this, if this is the direction of motion, so the drag force is in this direction. And that is the drag force is nothing but SV square D. See, just to substitute the given data, S is 0.5. Orbital velocity, I am taking nearly 8 kilometer per hour, approximately 8 kilometer per hour. 8 kilometer, kilometer per hour, it is 8 kilometer per second speed. Not kilometer per hour. Kilometer per hour, Lona Guda 8 kilometer per second. So 8 into 10 power 3 into density of the dust particles. 1.6 into 10 power minus 11. Roughly, I'm taking like this. So you'll get nearly some 6.4 or whatever it is. It is your choice. Newtons. Right. Now, at an instant, at a particular instant, when the satellite at a particular instant, when the satellite is at a particular distance, say V stands for its orbital velocity. Can you please help me in writing the total energy at this point of time? It is circular at that point. It is circular at that point. The total energy is minus of kinetic energy. Minus of half m v square. So you can write this, or even you can even write this one as G capital M into mass of Earth by at that instant radius 2 times R. So I will use RE for mass of radius of Earth and ME for mass of Earth. That is the total energy. Now the question is, if I take total energy in potential energy terminology, minus GME by 2R times capital M. So delta E So delta E refers to what here? G, M, ME at that instant slightly changing is the radius term. Here 1 by R differentiation minus 1 by R square. Right. 2R square delta R. So therefore, you want delta R is 2R square G capital M M E by delta E. Why there is a change in energy? Can someone please explain? Because someone is doing work. Someone is doing work. The thrust force is doing work actually. The drag force is doing work. So therefore, that work is nothing but F into 2 pi R. Yes, it's a closed path. 2 pi R. Right. Remember, in such cases, it's slowly the radius decreases and gradually it will fall onto the earth. That is called an inward helix. Sorry, inward spiral. It won't fall as of sudden straight line towards the center. It will follow in a decreasing radius path. And that path is called inward spiral. Spiraling inwards. And that delta E, you represent it as minus 2R square by 2M ME by 2M G. GM ME two pi R F. Already you know the value of F. So, right? So now you take mass of earth as 4 by 3 pi radius of the earth. Arya, you said close to earth. So R, Arya, close to earth. So then how you show a diagram? Almost R is close as RE తీసుకున్నాను అనుకోండి. Diagram ఏం చూపించగలుగుతాను నేను మీకు? So they said close to earth, starting near earth surface satellite. So therefore, almost 4 by 3 pi R cube rho. So that I will substitute over here. So this will become minus 3 F by G into M into rho. That is the expression for change in radius. They asked you to obtain the expression for find the drag force. Okay. Find the change in velocity and change in radius. Already I have given you the expression for change in radius. Right. Any doubt till this point, please ask me. So long the radius is R, why there is a change in potential energy? In one rotation, the change in radius is almost negligibly small. Now tell me. Now I have given total energy in another expression also. Change the color. You can write it as half mv square also. Half capital MV square. Hold on. Half capital MV square. So delta E is, you know the differentiation part, MV delta V. So clearly delta V is delta E by MV. Right. Delta E, don't forget a minus sign is there here. A minus sign. But delta E is minus 2 pi RF. So therefore, this will become 2 pi RF by MV. That's all. So I have given you expression for change in velocity. Notice change in velocity is positive. As it goes down, speed increases. As it goes down, radius decreases. So this you need to learn. So maximum problems I have covered. Nothing is left today out of what I have planned. And these are all excellent problems. One last concept which I need to teach, and thereafter I'll post these notes. Remember, in this part, one more important question you may be given, like this is the part. Radius of curvature of perihelion and eperihelion points. Very rarely people will ask this, but you need to just know this is geometry. It's not my role. It's the role of a maths teacher to teach you all these things. See, for example, you take at point A, for example, you take this point A. At this point, what is the force? The gravitational force, G(m1, m2) by distance squared, right? Suppose if it is acceleration, or intensity of gravitational field or acceleration. If that acceleration is just sufficient to make a circular track over here, so this acceleration must satisfy V square by R condition. I have substituted V minimum in that way. So therefore, I got R as, after all this calculation, A into 1 minus E square. But don't forget, this is B, this is EA, and this is A. So B square is written as A square, 1 minus E square. So 1 minus E square can be written as B square by A square, and overall it is B square by A. Please remember, at this point, radius of curvature is B square by A, minimum. Whereas both the sides, almost more or less. So at this point, radius of curvature becomes B square by A. Just remember that. Remember, minor axis square by major axis. Don't get confusion. Minor axis square by major axis. That is another point. Till this point, any doubts? But tomorrow, I have two things to do. One, I need to cover all previous IIT questions related to this chapter. Except, I think I'll cover including 24, last 8 years, otherwise. Some 20 questions. So I'll prepare questions gap the way how I've done today. So that now I have covered a lot of problems. If this has to be done in a class, it will take 2 different classes. By the way, you don't require to note. I'll post this immediately after the class. Any doubts? Right. So therefore, all these things I'll post it in notes, and I'll post that right now.